This is an LDO. It's a component that converts high voltage to low voltage. They're commonly found in many electrical circuits whenever a low power voltage rail is needed. But what if your circuit needs more power? Can you just combine multiple LDOs? A ton of people have asked this question. The main issue is that not every component is the exact same. For a 5V LDO, some parts might measure 5.1 volts, and some might measure 4.9. This difference in output voltage results in one supplying more current than the other. The question is whether this issue actually matters.
I'm going to wear my glasses to get the stone. I can move around, I cannot still...
To figure out, I'm going to design a board with multiple LDOs and measure how well they share current. This is the cheapest 5V LDO I could find. It's rated for 1 amp. The plan is to take 25 of them and wire the outputs together in parallel. I'm also going to add a 200 milliohm resistor in series to each one so we can measure current. Here's the finished board. Before we start testing the LDOs, we need somewhere for the output current to go. If I try to use this quarter-watt resistor, it'll burn up. But if I place that same resistor in water, it can dissipate more heat and thus handle more power. I ended up soldering 12 resistors together and submerging them in a bowl of water. I measured the individual output currents of all 25 LDOs and recorded that data in a table. I then increased the resistance of the load in steps, going from 1.8 ohms up to 22 ohms. To create a load with lower resistance, I used a couple feet of magnet wire wrapped up in a coil. I organized the data by load current and interpolated between points. We can visualize this data nicely with a heat map. Each box represents an LDO. The more red a box is, the more current it's putting out. The percentage shows how close each LDO is to reaching its 1 amp threshold. It's clear some LDOs consistently put out more current than others, possibly indicating that these specific ICs have a higher than average output voltage. It's also interesting to see that the sharing improved at higher currents. Our results ended up being pretty similar to what many people predicted. The current sharing across LDOs wasn't great, but we were still able to deliver 6 amps continuously with only $2.71 worth of parts.